So today we have a hard problem. This is about segment trees. The problem is we have list of numbers, and we have some value k, and we want to find k, and we want to pick k ranges optimally. So the maximum from range minus minimum, the sum of that would be biggest possible. So for this 2, 3, 5, it is 5 minus 2 equal 3. This 1, 2, 3 is 3 minus 1 equal 2. And the sum is 2 plus 3 is 5. Obviously this is not optimal, and the ranges shouldn't repeat, so we can't just pick all the range k times. This is not accepted, allowed. So I myself skip to hints immediately, and let's look at the hints. They are about using segment trees. So for convert this range of numbers into segment tree that answers the question what is the minimum of range and the maximum of range. If we have this, we can we should know another intuition. We can just use this as is. This is not the solution. The other intuition is kind of mind-blowing, and I adopted. I could find it myself. So the other intuition is that if we have some ranges, so we have numbers, for example, like this, and imagine that we have left pointer strictly at this position, and the right pointer can be any other. So we have this range, this range, this range, and if we look at the value maximum minus minimum for each of them, maximum minus minimum, the most optimal one or the most biggest one is this one, the most wide in this range. So if we shrink this range, we can we will not get the value bigger than we have for this entire range, because we imagine if we remove the maximum, then value became bigger because maximum minus minimum, and the maximum is the wider range is strictly bigger or equal the maximum of the sub-ranges. The same situation for the minimums. So that means we better start with as wide ranges as possible for all L left values. So we start from this range, and then this range, and then this range again. So we, for each left value, we're looking as far as possible. Okay, this is the second intuition that almost get us to the answer, but still not yet. The third intuition is how to pick k largest. So imagine we put all these ranges. We know they're kind of big as possible. We computed them in O of nlogn because we moving the only one pointer on the left, and we querying this as range with our segment trees. But if k is bigger than just n values, and we know that it can be big because subranges are n squared, how should we actually shrink these r pointers efficiently or optimally? And this where we use some sorted collection. So imagine we picked this biggest range. So we pick this range, and we have this range, and this range in the sorted collection. And after that, we use this subrange of this taken range and put it back in this collection. So that would give us a possible another value. Now let's look at the code. So this was my accepted version. I use Gemini to fix my errors because I have many of them and I don't have time. I already spent 40 minutes, but I was proud of myself because I wrote this segment tree myself, even so it was full of bugs that didn't allow me to pass this. Okay, let's look at the shortest version that I achieved today. This Kotlin one. It's pretty fast, by the way, from 700 milliseconds to 169 milliseconds, and I use it like single lines everywhere. The trick that Gemini is invented for initialization of n, you just go scan from last one, and this is in the array, so we can put left, right, and the result inside the query result, and it allows us to have some caches for the priority clear to not recompute it every time, and nice way to add this to the queue. This is the shortest version of the variant. Let's look at the Rust. Rust has nice supporting things that Kotlin doesn't. For example, binary heap, you can do just collect and it's done. Filter map that does the pop and map from the result, so it's only have none or some value that is filtered, and this is nice. Everything else is the same as a Kotlin, except this is lambda, not the function, and it allows us to catch these t variables. Okay, that's it for today.